Good morning, sir. My name is S. Niharika. My roll number is 23408048 from Department of ECE. Today, my topic is different modes of wave propagation in antennas and wave propagation. Introduction to wave propagation. We have two waves are disturbances that can transfer energy through a medium or space. Understanding the wave modes helpful in various scientific and engineering application. This presentation is mainly covers upon the types of wave propagation modes and their characteristics. Water waves. Waves are the oscillations that can be transfers the energy without the transfer of matter. The mainly wave can be classified into two types, mechanical waves and electromagnetic waves. This mode of propagation which can be determined how the waves can be moved. It may be either a medium or space. Mechanical waves. Mechanical waves which can be requires medium such as air, water or solids to travel. These waves can be propagates the oscillation of particles within the medium. The example of the mechanical waves like sound waves and seismic waves. Electromagnetic waves. Electromagnetic waves does not need any medium and it can be travels through a vacuum. These waves can be propagated via oscillating electric and magnetic fields. The examples of electromagnetic waves like radio waves and X-rays. Types of mechanical wave propagation. Mechanical waves can be classified into uh, longitudinal and transverse waves. Each type has unique particle motion relative to the wave direction. This mode influences how the waves can be transfer energy and the information. Longitudinal waves. The longitudinal waves particles can be oscillates parallel to the direction of the wave travels. Sound waves can be in air are typical examples of the longitudinal waves. This can be involves the compression and rarefaction of the medium. Transverse wave. Transverse wave can be inverse the particle oscillation perpendicular to the wave direction. Example can be includes like transverse waves or seismic S waves. These can be transfer energy through a shared motion in the medium. Surface waves. Surface waves can be traveled along the interface between two different media. They can be combined the properties of both longitudinal and as well as transverse waves. Surface waves can be common in ocean waves and seismic activities. Wave propagation in solids. Mechanical waves in solids can be both longitudinal and transverse modes. These can be crucial in understanding materials properties of the seismic activities. Waves in solids can be travels faster and with less energy loss compared to the fluids. Electromagnetic wave propagation. Electromagnetic waves can be traveled through a space at the speed of light. They don't have any medium and it can be flows through a vacuum. Their propagation can be which involves oscillating electric and magnetic waves. Polarization of the electromagnetic waves. Electromagnetic waves can be polarized, meaning that means that electric field oscillates in a specific direction only. Polarization which can be affects the interaction with materials and lengths. The important technologies of polarization electromagnetic waves like LCD screens and radio communications. Wave propagation in anisotropic media. This media which have the properties like vary with the direction affecting wave propagation. Waves can be changed speed, direction, or polarization in such media. The examples like the crystals and the certain biological tissues. Reflection and refraction. Waves can be changed the direction with encounter with the different media. This process is called as the refraction. Refraction can be occurs when the waves can be bounced back from the boundary. Both phenomena depends upon the wave and wave mode and the properties of the medium. Diffraction of the waves. Diffraction which can be involves the bending of waves around the obstacles or throughout the openings. It can be more pronounced when the obstacle can be size is comparable with wavelength. Diffraction is the significant in sound and electromagnetic wave behavior. Interference of waves. Waves can be interfering consequently or distinctively when they can be moved. Interference patterns can be which depends upon the phase relation between the waves. This phenomenon can be underpins the technologies like noise cancelling and headphones. Applications of the electromagnetic waves. The applications like electromagnetic waves are critical fields like medical imaging, seismic analysis, and telecommunication. They have the knowledge of the wave behavior, which can improve the design of sensors and communication systems. Studying different modes, which can helpful in understanding natural phenomena and the engineering solution. Conclusion. Different modes of the wave propagation, which can include mechanical, that can be longitudinal transverse surface, and electromagnetic waves. Each mode having the unique particle motion, behavior, and the application. Understanding these modes are essential and in the advancements of science and technology. Thank you for giving this opportunity.